Hello.
Hey there, how's it going?
All good, all good. Excited to discuss and find common concerns and solutions. Hey.
Excellent.
Hey, folks.
Hey there.
Hello, hello.
Remember to stay hydrated all the time. Hello. Also, if you hear a washing machine on the back, my bad, washing clothes.
Hi.
I think I have one worse than that. There's a dog park right outside my window.
Oh no.
Windows only help so much.
Better Linux, right? I'm gonna stop.
Right, there's 14 of us here so far. There's 19 people on the agenda, so we'll just give it another minute or two and then we'll get started. All right, that list seems to have settled. Hello, everyone. Welcome to the GraphQL Composite Schemas Working Group. This is the second meeting. By attending, you will have agreed to the specification membership agreement, the participation guidelines, the contribution guide, and the code of conduct. If you're not familiar with those documents, A, you probably shouldn't be here, but B, there are links to them in the agenda. I'd like to ask if there's anyone who's willing to take notes. Huge thanks to Bobby and Tim for taking such excellent notes last month. The links to the Google Doc for the live notes is again in the agenda.
I'm happy to help out.
Fantastic. Okay, so first of all, a quick introduction. Last month, we actually did a more full introduction. So if you're interested in seeing what different people's motivations are, you can go and read that, watch that video on YouTube and see who different people are and what their motivations are. This week, we'll keep it quite short. We'll go through in the order that is in the agenda. So that will start with me. Hello, everyone. My name is Benji. I'm from Graphile. Next, John.
Hey, I'm John from IBM.
Sahaj is missing.
I think Joey, you're next.
Sorry, I can't see the order. Hey, I'm Joey from PayPal.
Hey, I'm Derek from Apollo. And Michael.
Not here.
I don't see Michael, Jonas, or Doc on the list.
It's see Stefano. So, hi, I'm Johnny from Unison.
And I'm Predrag. I work at Kensho.
Hello, everybody. I'm Paolo from Nearform.
Hey, I'm Lauren from the Guild.
Hi, this is Agatha from Tyke.
All right, this is Jason Webb from Intuit.
Hey, I'm Julian. I'm building GQL.app, a GraphQL ID.
Already disappeared, so I think I'm next. So I'm Uri from the Guild.
I think I'm after Uri. I'm Mary from Apollo.
Hi, I'm Yaakov. I'm on the call. I still need to add my name to the agenda. Sorry about that.
Did we miss anyone? Anyone who's not introduced themselves?
Matteo, hi. I am adding myself to the document.
Excellent. Thank you, Matteo. Yeah, so anyone who is not in the agenda, please send a pull request through with your name to add yourself there. We like to keep a record of who's attended. Okay. So next thing to do is to review the agenda. There haven't been many items added to the agenda this month. The subschema composability rules, which Yuri, I think, will be leading, and the next steps for the glossary that Lauren's been working on. Is there anything else that people would like to add to the agenda? No? Okay, well, then we'll move on. I don't believe there were any explicit action items from last month, but I do know that there was a lot of talk of all the different things that we could do. So if anyone wants to talk about any actions that they've done that aren't covered in that won't be talked about later in the agenda, now would be a good time to bring that up, to bring discussions to people's attention and so on.
I'd love to get a sense of whether folks had a chance to take a look at Yaakov's composability rules and some of the surrounding discussion.
Yeah, I'm hoping that that will be covered in Yuri's topic in just a moment. But yes, I would also like to know that. Since there is no input there, let's move on to the subschema composability rules. Yuri, did you want to take this?
Yeah, so I added it because I didn't know if Yakov would be here, but he's here, so that's great. So I don't have, I think, a lot to add on top of what Yakov would say, but I read through the doc. I think it's a great base for kind of like. I think the more I talk, the less it will be interesting compared to what Yakov would have to say. So for me, it's just I read the doc; it was very interesting, and I think. Once maybe Yakov could review the work that he's done already and some of the reviews he already got, then I hope we can take the conversation of like what would be the next steps and action items that we could take to move this forward. So Yakov, if you can talk a little bit about the doc. And yeah.
Okay, I'm gonna try to talk a little. Can everyone hear me?
Yes.
Okay, I do apologize. I'm technically on vacation. So technically in the car, technically with 6 kids in the background. So if it doesn't work out to hear me, just let me know, and I'll luckily, I pretty much expressed what in terms of the composability rules already in the document. I'd love to hear people's feedback. I mean, that's the main thing. So luckily, my thoughts have already kind of been expressed. In terms of it's a first draft, so there may be errors in there. That's first of all, of course. I've really appreciated the feedback from other people that has already been added to the document. The more people that weigh in, the more correct, I guess, it could be. I think I tried to keep it broad in order to cover the 2 main execution modes. That's sort of the lingo that I use within the document, meaning the 2 main ones are execution as a single service versus execution to the existing, to the sub-schemas that were the objects of the composition. And they do, in my view, have different rules in terms of composability to some extent, with the single service model being much more flexible. The way that I took from that is that while we may want to, is that the more interesting, so to speak, or more complex case is when execution is to the original subschemas, and that may requires a little bit more careful fine tuning. Although and that happens to be the case that I'm more interested in, is that my background came to this whole working group comes from my work on type merging within schema stitching. So that's basically what I came from. My thoughts in terms of next steps was actually to work on some code that that can validate whether given the subschemas, I was thinking of in terms of actually creating some code or algorithms encode that that represents the quote unquote rules that we have so far in parallel to the GraphQL spec and the GraphQL JS working group. I'm not, and then in theory we could keep going and create algorithms and code for the actual runtime execution. I'm not sure how interested people are in that, like a sort of a reference implementation of that. But those were some.
Okay, great. Thanks for that, Yakov. A really significant amount of work has clearly gone into this, so that's excellent. You mentioned that you had based this on your knowledge of schema stitching. Do you know how compatible it is with the other approaches to composite schemas currently? Do you have a feel for that?
I think that, again, I only have a small feel for it, but I think that for Federation, for example, I think is more strict rather than at the current time. And I think maybe appropriately so. I don't know if it's necessarily a good idea to, in terms of usability, to be as lax in some things in terms of enums and input fields and etc. That's my general sense. But if there's anyone on from Apollo who wants to give a sense, I think that the merging in some other gateways is, for example, only in object types. and that again would be more strict. So I think we're generally in good shape as sort of having an upper bound, and then everything in terms of what actually breaks composability, and then layered on top of that, we could have additional layers of warnings. But that's a great, definitely a great place for feedback from others.
Has anyone managed to read this yet and got any feedback? I see that there are a few comments on the thread already. Matteo.
The way name spacing and the concept of transformations happen, it seems quite heavy as an operation to be performing it for every request, essentially. So constantly remapping everything and so on and so forth. Something that's missing as part of the of GraphQL itself, it's a concept of a namespace or a module or whatever we want to call it. So maybe it would be possible to add that instead of doing all this renaming. Just add something in front, like essentially a module definition or whatever, instead of renaming everything.
One thing I find useful about not using namespaces is we can present what looks like a unified schema to our customers. So something that from a user perspective has no need for a namespace, they're all in the same place. And maybe if the namespace is as simple as prefix every type with, the same name, maybe that would work fine. But it's nice to have it all in one simple flow for them. They don't see a reason why there'd be a module over here versus over there.
Yeah, but maybe you can also treat namespaces as an internal thing that you then expose as a single schema also, or as a composition tool.
But it actually depends whether you do the name spacing at build time or runtime. Because if you do a build time, we could, let's say, just an example, we could, the remote service, the other services might realize that their schema has been renamed, only use the final rename types, and no longer have to do the renaming dynamically as Matteo was willing not to. There might be a way to solve it.
Without having fully read the full document that Jakov prepared, I think for namespacing, there's also the question on whether those two types actually represent the same underlying entity or whether they are truly two different things in each service. So depending on that, there would maybe even be no need to actually namespace them, but rather to merge or compose them to a single thing.
Jakov and I chatted a bit on the document about what it would mean to opt in to merging and composing rather, and what that means for a client that's trying to compose them. So if I'm trying to compose two schemas that didn't intend to be composed, would they have the same meaning for the same type? And should you provide metadata of some kind that would allow them to merge with a specific transform on them? I don't know how useful that is. That's still up for discussion, of course.
Yeah, I think just mindlessly merging them would probably go wrong. So I guess there needs to be some metadata for identifying those cases where something can be merged.
Also, if a query fetches the type name meta field, that might get interesting with respect to renaming and namespacing types, I just realized.
When you talk about metadata, we're talking or do something about the type name that we already have, something similar to that.
I think there are today.
To,
sorry.
Sorry. Are you referring to introspection, Predrag?
Yeah.
Yeah.
So it will use the introspection in advance of running the operation in order to get the metadata associated with the types, different types.
I'm not
So
actually
for
sure
the,
we can.
For the
we
metadata
can
one, there's actually a proposal by Benji and actually there was also by Lee to actually talk about how to expose some of this metadata to introspection and to make it, it's outside of this working group, but right now, as far as I know, for most part, this sort of extra metadata can only be provided through like an SDL, because in introspection, you won't have that sort of information available at this point. But again, there's a separate proposal for having the metadata through introspection. Take a look at it. Lee, I think, posted that like a couple of weeks ago.
I'm also not really convinced that we can always separate the execution of the introspection portion that fetches type name and such from the rest of the query, because I think it's semantically legal to ask for a combination of introspection and regular data, and implementations won't prohibit it, even though it's not commonly done that way, and you know, use cases are rare.
Actually, that was exactly my point. It's not that everybody's using GraphQL or similar to see in advance what they're doing the introspection. They should be able to directly reach out the server and say, give me the data, and from what you return me back, I will then use them the metadata, like just an example, type name, to see what I'm doing. I completely agree with you. That's we should not rely on introspection, especially because, as I seen on many objections, for very large schema, the introspection query might be never ending. So that would be a huge waste of time, especially in mobile scenarios. So we should not do that.
I've had that problem in practice. So yes, that is exactly my concern.
Yeah.
I believe the slow introspection query issue is mostly around like if you're using it for runtime composition. If we're doing like a build time composition, that shouldn't be an issue. But those are two different approaches to do that, right?
I think you can be forced to evaluate introspection at runtime with sort of unpredictable results, because TypeNim has to fetch the exact type of a thing, and if a field only returns an interface, then, you know, like a list of interface type, and I ask for the type name of each of the elements inside, then you're going to have to actually look up what that type is, and that will be at runtime regardless of when composition is happening.
I have a more general question. Do you think that we should go to a route where we have rules for namespacing that can be inversely used by clients to determine how the namespacing and composition was done, or not? We don't set up general rules like that.
From my perspective, it was important to maintain the ability to compose schemas that that you do not manage, and so I'm not sure if that directly relates to your question, but you know, I think you might, as someone mentioned earlier, you might want to compose schemas you don't manage, and for better or for worse, you might want to hide the fact that that data is remote and presented as a simple, you know, GraphQL schema. So I think we want to preserve that ability to create a unified API even from remote services that you don't control.
I see. I mean, it actually kind of answered my question. Now, the composition, let me pass the term. Composition engine will have to do the composition anyway, so eventually they can apply the same composition rules and so forth, or they can completely dismiss it and use something else, depending on the use case. But what you're saying is not prevented, because at some point something must be composed the schema and aggregated, if, especially belongs to remote services.
I think a number of problems come up when you're trying to say, I don't own this schema, but we need to merge it anyway. Namespaces seem to help with that. At least it seems that way. I haven't used them myself. But maybe there's like a dividing line there. If you don't own the schemas, you want namespaces. If you do own them, then you try everything in your power to make them work together without them.
I would argue that namespaces would be still useful if you have like two teams working on the GraphQL service and they define the same type, but they mean different things. That was mentioned before. Maybe they shouldn't be merged and you still need to do renaming of it. And it's kind of like still somewhat useful.
Yeah, we actually do that at PayPal.
Yeah, yes, I agree, but this goes against Jakob's requirement of being able to compose schema that you don't actually belong to. I mean, that you don't have control on and so forth. I mean, if you control all the sub schemas, yes, you can do it. You can and you should, of course, because less mess for everybody.
Well, I mean, we might be talking about two different things. If we're talking about how to merge schemas that might conflict, that's definitely the ballpark of you know, what I'm talking about. Merging, composing, I should say, remote sub schemas that you don't control. You may need to, you probably will need eventually to use transformations of those sub schemas to make sure they don't conflict. Of which namespacing, you know, one of many different techniques would be helpful. If we're talking about namespacing within the sub schemas as a way to avoid conflicts, I mean, that gets into where the metadata about composition should live. Should it live within the sub schema? And you know, I'm generally more interested in that question of how to merge sub schemas you don't control. And so obviously, then the metadata can't live within the sub schema. And so that's just what happens to be what I'm interested in, and therefore, you know, preserving that as a possibility is important. So namespacing might be helpful within a sub schema for many different reasons, and I know that's been brought up in the GraphQL general GraphQL spec working group, and it might be helpful specifically for composition. But it's helpful. The way I think about it is namespacing is a type of transformation that's helpful for composing sub schemas. But I want to make sure that the way, in terms of implementation, that it doesn't have to be defined by the sub schema itself. It could be, maybe, but it doesn't have to be.
A little side note, I can add you that I mean, in my opinion, the case that you are proposing where you don't control the sub schemas is the most complex. So if we solve that, we have inherently solved all the other ones, because you don't control the remote schema. You can't say whether the types will collide or not. So if you solve that one, the other one are solved by just by simplifying the cases, right? Because that's the most complex. Another side note I was thinking about, that and also namespacing is the easy way to solve it if we can make it fast, because which was Matteo's concern, because if you have to runtime rename and so forth, it will become, all the implementation will become slower. So that's the concern. I mean, if we could even add the metadata in the extensions field for what it matters. We could definitely do that, but I don't know.
Regarding the slowness, what's the use case here? Like, do you talk about on-time merge GraphQL schemas for executing an operation?
So there are two issues with from an end user perspective. Okay, exposing a single graph that have no namespace information in it provides some more user-friendly or more intuitive, probably, experience. However, that system masks completely the complexity of doing this merging. The reality are that if I have two parts of the graph that I've developed by two separate teams, they need to coordinate a lot to make all of this work and not break everything in reality. I can totally see the fact that in certain organizations or companies, they might want to say, okay, no, I'm just using some concept of exposed, some concept of namespacing, or maybe even, exposing the namespaces in a way that is it's clear where they came from, and to avoid conflicts. Okay, so essentially, if let's say similar to how you would have a SQL table, that you could use the SQL table just identifying the SQL table with the table name, but if you want to get the table from a different database, you could just prefix the database name and get it there. The reason why I'm talking about this is that having this kind of system will make it very flexible and avoid a lot of conflicts and complicated situations. Like, things will just possibly work out of the box in a lot of cases. However, basically bumping that problem to the end user, that then they will need to know that these things come from multiple places and so on and so forth. So yeah, that's it really. So it's that's the concern is that the moment you are you need to take and have the right fields and the right things on the fly, it will be there is a lot of bugs that can go wrong when you do those kind of transformations in real time for every query that comes in. Like, a lot of possible bugs, a lot of possible things that can go wrong. Like I tried. It's not simple. Okay, I would rather not to, like, if doing those kind of transformation is, I will probably not want to do that to some extent, in a production system at least, because otherwise it's not simple to maintain. That's my and it's going to be, somewhat performance wise, like, although translations are always like not super good. Anyway, that's me.
I'm not
introduce another.
Sorry.
No, I was just going to say there's another use case that kind of is related to this that we kind of approach, which is Yakov said he wants to merge things that he doesn't control, and sometimes you do want to merge things you technically have control over, but you don't want to control because it costs. So, for example, trying to control things means that you have to go through a schema design process, figure out where things belong. Maybe you don't want to do that. Maybe you just want to say, hey, do whatever you're going to do. We'll put you on the graph. And then over time, as you see overlaps, this is kind of the approach that we take. We start to create a real schema out of the actual stuff that did overlap. So what we do is we just let people onboard to the graph in a namespace, and then we watch for commonalities. And at our own pace, we build up a shared schema based on the actual use cases of our products. Because if you try to control them out of the gates, it's a really expensive schema design process, and you're blocking your products trying to coordinate everybody. So we do really want to merge things that we technically control, but we don't want to control, if that makes sense.
General question here, but when we talk about composing schema and eventually use namespacing, if I understand correctly what we are trying to achieve here, the namespacing would happen at the operational level, so either a query or mutation. It cannot happen within a query. We cannot happen that a query is internally referring to another service, right? It should not happen, or not.
Why would it not?
I'm just thinking out loud. I'm just trying to understand if it can happen or not. Because if we assume that the schema is split in different, let's talk about the remote services case, which is the worst, right? The local will not change a lot. if you are thinking, let's say that we have, I don't know, just to make an example, a user service and a article service, right? Is not that, and if these are handled by the different remote servers, I mean, service, whatever you want to name that, it's not that within the user query, I'm referring to fields of the book service, because I should probably not expect that the user service can directly talk to the book service. Otherwise, it becomes insanely complex, right?
In real world use cases at Kensho, we've had systems that are able to refer to data in each other. So in principle, over the composed schema, a user can ask for data that starts in one place, crosses a service boundary, and then crosses right back, and then does so an arbitrary number of times that the user might specify. So
just to say, sorry, saying that if I ask for my user, and I ask for my books, the user service will talk directly to the book service, or the composition service will talk to the book service and replace at that stage in the query. Which case are you talking about?
In our implementation, you'd have a metadata service that you'd ask to essentially give you an execution plan for your query, and then it's all done client side. The services like don't talk to each other at all whatsoever. It's one client that gets an execution plan that says ask this service for X and then ask this service for Y and so on. So in a sense, the composition logic is housed in a service, but the execution is all client side.
I see. I mean, wonderful.
Yeah, and this has some very nice advantages. I'm happy to talk about if you're interested. There are good reasons why we did this.
Okay, I see. Okay, that answers my question, because if you were successfully able to implement it, it means that somehow probably we should implement at the spec level.
Going off of, oh, sorry, go ahead.
In general, the thing that, for me at least, sort of mentally has been helpful is not necessarily assuming that the actual composition, either execution or like schema, operations themselves, have to be done by some service as opposed to the client, right? Like the metadata for how the composition happens should be equally possible to execute on the device that is, requesting that the query be performed, and the device that houses the data that describes how the different schemas combine. And those two, in fact, might be the same device even. Does that make sense? So even trying to avoid the client versus server separation whatsoever from creeping into our terminology.
Which is amazing. I mean, I'm not saying it should not. I mean, it's a very brilliant idea. But the thing is that it means that at some point we have to encode within the spec a way to recognize that at some point run this query up to this point and say, oh no, this one must be go to this other service. So there is also in this case there is also a synchronization problem, because you first have to wait to the parent service to finish and then eventually go to the child service, or maybe not, and just go together and eventually you discard the later results. I mean, it also introduces a concurrency problem that we're not even analyzing at the moment. It's very bad very soon, I guess.
And to be clear, this makes the concurrency problems that exist more obvious, but they exist regardless, right? Like even if services are talking to each other, the schema might have changed in the middle of you executing your query, and your query might have been valid previously and is invalid in the middle of its execution. So it's not great.
Yes, of course. But at least that one is a temporary error. If you retry right after, you should be able to get the right results. I mean, it's just you were just unfortunate, I would say. But I mean, yeah, but I completely see your point. I see that.
I think if I understand your question originally correctly, you were asking if each subservice is aware that it's being composed and talks directly to the subservices. I'm not aware of any existing composition solution that works like that. Sounds to me, just in terms of thinking about it, that it's sort of like a more mesh-like approach. And I think you might run into like like looping problems that, where, to make sure that that query can actually end. I think all the composition services that I'm aware of, and I'd love if people would chime in to see if that's not true, is that they work through the way described, in which there's some sort of gateway, whether it's operating on the server or the client, as mentioned. Schema stitching can run on the server or the client. But I think another thing that your question sort of touches on is it possible that one of the sub-schemas itself is actually a composed schema, and that's certainly possible. Certainly it would be possible if a sub-schema is remote, you don't control it, you might not even know that it also is a composite schema. But you wouldn't.
I mean, the reason of my question was, I see a point that even sub-schema can be complete, but from the perspective of the parent, I look at them as a giant schema. How I get the data from them, I don't care. I would assume like that. Otherwise, we never end. But I see your point, probably, yes.
Having sub-schemas know about each other prohibits you from moving things around, whereas if you put like a map, a composition map in front, you're able to move things so that the sub-schemas don't know about each other.
Yeah, I think this has been a really interesting discussion. And I think quite a lot of it comes down to this problem that we described last month, which is sometimes you want to compose schemas that you do control, and sometimes you want to compose schemas that you don't control, or at least that you want to pretend that you don't control. And one of the things that we keep coming back to time and again is talking about this data, this description, or this metadata. And as mentioned, there is work ongoing at the GraphQL working group at the moment to do with metadata and managing that. But obviously, in the case of a schema that you don't control, you can't put metadata into it. It must be external. There's also been a fair amount of talk about namespacing. The namespacing that Yakov has proposed here is in the form of just renaming fields, which is totally fine, because at the end of the day, you don't necessarily know that it's happened. It just looks like a naming convention. I will say that the topic of explicit namespaces like foo.bar kind of thing has been proposed a few times at the working group and generally hasn't made much progress. That isn't to say that it will never be added, but I think the bar for adding it is quite high. And I think one of the main reasons behind that is because GraphQL focuses on making a schema that is designed to be consumed. It's designed for the client. So it's expected that we on the server have to put in a little bit more work in order to make the client's job easier. So we shouldn't necessarily be exposing these kind of complexities to the client in general. But that, of course, there are service to service GraphQL and things like that. So this isn't like a hard rule. It's just a general guidance. Another thing, as we've talked about, automatically renaming things, and that is often what people want to do with the namespacing. One of the big issues that comes out of that is an explosion of types. If everyone does, for example, cursor pagination, and they all have a page info type, you may end up with 18 different page info types from your 18 different microservices. Maybe some of them have a total count field and some of them don't, or things like that. So they're not entirely compatible. And things like that, it's best, I think, to have explicit rules on whether those are merged or whether they're renamed. I would like to continue this discussion, and we have booked 2 hours for this call, but we have been talking about this topic for a while. So let's move on to talking about the glossary, and then we can circle back to this at the end of the meeting. So Lauren, if you'd like to talk about the glossary.
Yeah, so after the last working group, we all agreed that currently the words that we're using for describing certain stuff related to schema composition is very vague, and different terminologies used for different specific libraries or in different programming languages. So the idea here was to create some kind of a glossary where we have a unified language, or like collect terms that everyone can use. So if someone talks about anything related to schema composition, we kind of have this common language and we understand each other, and we're not like talking, we kind of can't understand each other. So I created this PR for a document that I started internally because we had the same problem within our team. And yeah, it's right now it's kind of a collection of terms for describing certain stuff such as sub-schema or composite schema, but also there is some branded terms, for example, Apollo Federation, the Guild schema stitching, and also some kind of different solutions for schemas, for schema composition. So I actually wanted just ask everyone, or like send a call for feedback and reviews, so people actually like add missing stuff, review stuff that is already in the document. If you are aware of some kind of schema composition solution that is not yet part of the glossary, add it, or yeah, that's basically all I want to do, is like make people more aware of this document so we kind of have a collection. And then the next step is probably also to divide it a bit. So right now it's everything in there, but maybe the branded terms should be a separate document, or maybe an appendix to the glossary. And then also the actual implementations that are open source or our hosted solutions should also be a separate document or appendix. So then everyone who wants to do anything in the schema composition space has a document you can look at, and from there see all the different solutions that are already there, and then maybe pick the correct one for their use case, or in the best case, all of those people gather here, and maybe we in the end have one true solutions for all the problems. So yeah, that's actually everything I want to say today. Thank you.
Excellent work on this, Lauren. Like, it's really useful, I think, to have this shared vocabulary that we can all use to talk about these different things in a non-ambiguous fashion. I've had a look through, and yeah, as you rightly point out, I think separating the more branded terms from the more generic terms would be beneficial. I think the more generic terms are the things that we could ultimately use in whatever form of specification we decide to build as part of this working group. For example, you know, we came up with the terms last month of things like the sub-schema, which I see is in the glossary, which is fantastic. So yeah, excellent work there. What do you think the next step for this would be? Just feedback from people?
Yeah, so one thing is feedback from people to actually have a look at there and fill in the missing parts. And then for me personally, I think the next bigger task is to split it a bit. So branded terms, actual implementations, and the actual glossaries or terminologies are separated. And then also, ultimately, we need to figure out where we want to put this stuff, because right now it's a PR that adds a docs folder or something like this. Yeah. So I'm not sure if this working group repository is the best place for it. So you probably know better, or maybe anyone else has some kind of idea.
Let me propose that you split it into the two files as discussed, and you send them both into the RFCs folder. It's not the not necessarily the ideal location for it, but I think it's an acceptable location for it. The main advantage of having it merged is that then people can start sending pull requests to it adding their own keywords, also maybe altering or suggesting alterations to the definitions. And I think we'll be able to iterate a lot quicker that way. One of the key things in the GraphQL working group about the RFCs folder is that it has a very low bar to getting things merged into it, like generally like a cursory glance to make sure it's reasonable, and then it goes. We could use an alternative folder. I noticed that you've suggested docs, but I'm a little bit concerned that if we do something like that, it may add additional weighting to this document, which I'm not sure that it's ready for yet. Whereas the RFCs folder explicitly disclaims that and says, you know, there, just because a document's here doesn't mean it's official. It's just work in progress stuff. What do you think? Do you think that seems reasonable?
Sounds good with me.
Excellent. Well, would you like to take that as an action item then?
Yes, of course.
Excellent. Thank you. Did anyone have any, go on?
Would there be any interest in defining a sort of anti-glossary, for lack of a better word, of terms that we should probably try to avoid, because both in the last meeting and in this one, we kind of touched on the whole, like, if we use client and server, it kind of presupposes a particular way of going about things. As just one example of you know, 2 words that might be useful to have in that file and the reasoning there.
That sounds like a brilliant idea.
Yes.
I noticed that Yakov in his pull request also had a series of words that he said, I'm not using these deliberately. And I think we should, yeah, that would be very beneficial.
And a more tactical question for Lauren and Benji. I noticed that most, if not all, of the things that are currently in the glossary are things that are either sold as a service or are open source and available for everyone to use. Unfortunately, the work that I've done at Kensho is mostly, but not entirely, open source, and some of the most exciting Federation stuff is pretty deeply tied into our services and didn't make any sense to open source. How should I go about mentioning this, either in conversations or in the glossary, or just in general in these talks? What would be useful? Because I think it has some interesting design points, but I can't really point to direct source code, and you can't buy it as a service.
Yeah, I think that's a really great question. One of the things that we said about last month was that we'd like to gather use cases. So use cases aren't just the client use cases of like, I'm building a service that does this, but also things like the existing solutions, you know, Apollo Federation, schema stitching, and so on. And I think if we could have somewhere, I'm not sure where, a document on each of these, that would be very beneficial, because as much as anything, this working group is about finding the commonalities between these and then trying to take away some of the reinventing of the wheel that seems to need to go on. So like if we can standardize some form of metadata that then everyone can use, that would be beneficial. You know, if we have, I don't know, naming conventions that we could standardize, that would be beneficial. And by being able to look at each of these different solutions and see how each of these problem spaces matches up to each of them, I think that would definitely be beneficial. Where should we put it though, I wonder? I think another root folder, like the RFCs folder, with a suitable README in it. Would you be interested in taking that work on, Predrag? It should just be like a paragraph or 2 in a README, and then opening the folder to other people to submit their own documents to it.
Yeah, that definitely works. Alternatively, if Lauren would like to split this file, I'm happy to just add another, you know, like H3 entry and just write, you know, write a couple of paragraphs, reference some of Kensho's blog posts on the architecture for folks that want to dig in, and just summarize the relevant bits. I'm not convinced that it needs to be its own like top level file. It could just be another, you know, entry or set of entries in here. No preference between the two, whatever Benji and Lauren, you two prefer.
Does anyone else have any thoughts on this?
I think it makes sense to put it in the glossary as well, or the equivalent whenever we split it out.
I added a comment to the PR, but just to open it up here, we use the term namespacing a lot. It doesn't always mean the same thing, and we have like, you know, prefixes and this and that. Maybe that's something worth putting in there and defining what are the different ways we talk about that. But I'm not sure actually what suggestion I would give.
An approach I learned from the Rust community is when there is a lack of consensus on the name to use, just pick a name that was obviously not going to be the one standardized. So for the keyword for raising, throwing, you know, whatever exceptions, they decided to use yeet. And if we can find something that is similarly, would be equally objectionable to everyone to use instead of namespacing or whatever it might be, something like that might be a workable solution.
I think Joey might have been getting at there's multiple kinds. Maybe we want to define terms for each of them. I'm not very familiar with namespacing, but it sounded like there was prefixing and there was also some kind of metadata driven one instead.
Okay, excellent. Thanks, everyone. So I think what we're talking about here is 3 separate documents. One is a glossary of the generic terms that we intend to be using as part of this working group, which I think we can call glossary. Another one is a list of the vendor terminology that different vendors use, and this applies to open source projects, internal projects where you're doing this, where people can add their own things, add a description of what it's doing, just to the one document. I think that's fine. And also a terms to avoid, that is things that are branded, misleading, or ambiguous that we might want to avoid. One big question that I have for you all that I'd appreciate you thinking about, as I mentioned before in the previous topic, is this concept of data. Is everything that we need to do in terms of composing schemas doable from purely data, or do we sometimes need code? Ideally, if we can just do data, then this makes our problem a lot simpler, right? But I'd like to know from people out there that have these solutions already, is there a need for code in order to solve certain of these problems, or will metadata suffice? Don't have to answer now. Take it away with you. Have a think.
In my opinion, if we do a convention-based approach, then code might not be needed. If we follow strong conventions like Passmeter, Ruby on Rails White, where just by looking at name, you know what something is, right? And we can use for namespacing and similar. If we do like that, maybe yes, additional code is not needed. Otherwise, probably it is.
I think it should be doable just as data. I mean, there may be multiple rules, for example, for how to rename types. With sufficiently many rules, this becomes indistinguishable from code. I would like to keep that set to a minimum, but I think we should be able to pull it off without code.
Okay, well, I think we're done on the glossary topic. So I did say we can return the conversation to the previous topic. I've been made aware that the calendar actually only booked us for an hour. In the agenda, it is in fact 2 hours, so that's a bug on the calendar. But nonetheless, I don't want to necessarily drag this conversation on if we feel that we're at a point where we're ready to stop. I would like to capture some action items. We've already done so with regard to filing the glossary documents and so on. If there's anything else that people think we could take away as an action, now would be a good time to discuss those. Otherwise, if anyone has any other business, please speak now.
I kind of wanted to know. Oh, I'm sorry, Uri. Go ahead.
I just wanted to bring back actually, like, to talk a bit about the previous subject on Yakov document. I think, you know, we went to all kinds of like areas there, but I think if I understand correctly from my perspective, what Yakov is doing there is finding the most basic rules that we can agree on of what does it mean to compose schemas. And then, you know, and I think later on we can talk, once we have this, like the basic thing of what is composing and what is not, then we can think separately of how we can solve if it's not composable. And that could be like, you know, namespacing and transforms and metadata. And then we can also, after that, talk about where all those things sit. Like it can sit inside the service if we have access to it. It can sit outside of the service if we don't have access to it. But I think the core, in my opinion, what I really like about what Yakov has done is like he took the core problem of what does it mean to compose schemas and what schemas are composable and what not. So what I wanted to ask is like if we could create like an action item where I see this document basically maybe at the end becomes kind of like a test suite or so of sorts, right? Like where we can come up with all kinds of tests and all kinds of scenarios and see where they should compose and where they shouldn't compose, what is legal and what is not legal. And so I think Yakov is working on schema stitching, so I guess he has the best knowledge about that particular implementation. But what I really hope is like that people that use and build other implementations would go through it and confirm maybe that this is the basic thing also in their implementation. Because then if we can agree on that, we can move on to the next part, which is how do we solve schemas that are not necessarily composable or come up with all kinds of use cases like that. So yeah, so that was my thing.
And it would also be valuable to find out if the rules don't match, then why don't they match? Because that helps us to understand our domain a lot better as well.
Yeah, exactly.
So just to clarify, are you talking about making practical example of different problems that might arise while composing schemas? I mean, I'm talking at the type level and everything that eventually later might become a test suite for implementers. That's what I was going to ask, exactly what I'm going to ask. So huge yes from me.
Yeah, and I feel like in the current structure of how Yakov built it is like a great setup for this. Like it's built in a way that is like that. So I hope like that people that are creating other implementations would look at that and confirm that this makes sense, or there's stuff that are missing there, or things like that.
So there's definitely an action item here for everyone to have a look at Yakov's proposal.
Hi guys, I'm sorry to interrupt. I just unfortunately have to sign off. There's one thing, I'll be checking the meeting notes. There's one thing that I would like to get feedback on is whether people want me to work on a code implementation of the validation and the runtime composition. I mean, that's significant work, but I'm excited to do it. I'll probably be doing something similar in terms of in the long term, just to make sure that the schema stitching works with defer and stream, or unless some other open source implementation comes out first. So I want to know if that's something that should live as, you know, sort of as part of a reference implementation, that validation and runtime composition, or shouldn't, and that'll sort of affect, you know, where I do that work.
I think certainly the test cases for it should live in the RFC. As to the implementation itself, I have no strong feelings on it one way or another. The only concern that I might have is what language might that be written in. and you know, everyone has a favorite language, and so some folks might feel left out.
So the implementation I was planning was parallel to the GraphQL reference implementation in JavaScript.
I also agree with the test suite idea. I think including good examples and like a, you know, given A, then B, then C, how does it compose into D? I think that's good.
One thing we need to be very aware of when we're doing this is not limiting innovation. So we don't want to be overly, this is the one way that we must do this, I think. So when it comes to something like a test suite, that does feel like it's locking things down to you must do it this way. And I think it would be better to maybe spend more time exploring whether that is, you know, the one way that all of the existing solutions already follow. So it's obviously the right way to do it. So let's go ahead and do that. Or whether actually the existing solutions do this in different ways and there are reasons behind those. And if so, what is the common bit that is worth specifying and maybe writing some tests around?
I completely agree. We could write a test suite that goes by negative asserts. Let's say if you have two schemas that define the type, I don't know, user, the final compose schema, let's say just an example, should not take the type user, but you're free to disambiguate as you wish.
At least the way that I saw the test suite, it was more, if you have two sub schemas that look like this, they're composable in X situation and not composable in Y situation. And I personally found the rules not objectionable and perhaps even, you know, self-evident. But totally fine with going with what y'all feel like.
Maybe the name test suite is probably misleading. It's more like a rules suite, you know.
Yeah, that's kind of how I thought about it. Like, we should all be able to agree whether two schemas should be composable or not composable for the purposes of this working group, at least, I think. Because if we can't agree on that, then we're just talking past each other.
I mean, at the end, we just agree that schemas can be composed and there is no ambiguation on the client service plus meta-term side. How we reach that point, we don't care as long as the client is able to understand it, probably.
Just one quick thing on like as I kind of looked across the space and like the different solutions that are out there, like it seems like the ability to capture the metadata to like inform the runtime system how to execute the queries to navigate the remote schemas, that seems to be like a fairly large like differentiator in between, you know, from like actually annotating, oh, this is the query, so go get an ID, or you use a certain ID, annotation to say this is the ID, and then underneath the infrastructure knows how to do it, or linking, you know, keys and identities and external. So there's different mechanisms that different vendors have kind of come up with it. How do we sort of think about like unifying that? Because like merging the types is one thing, but then also giving enough metadata around it to sort of allow for that execution. That seems to be like, and there's different trade-offs in there, right? Like one is like very convention, you know, you can use very convention and you capture a very little metadata. And then there's systems that have almost no convention, but they're very flexible, but it causes developers to put a lot more metadata into the schema. So you sort of get that breadth of solutions in there. So I don't know, I just think that would be an interesting topic to sort of get, you know, I think there's a little bit more than just merging the schema to it.
But I have one question here, because I might lack some knowledge here. The GraphQL spec does not define any metadata, right? So when we talk about some metadata, we are just talking about data that the receiving end knows is metadata, right? There's nothing in the spec saying, oh, look, this field is actually a metadata field, or am I wrong on this?
No, it would just be like, I mean, typically I think there's like your directives that are used by different systems that are interpreted by infrastructure that allow it to execute. From what I've seen, there's different, you know, that's sort of the extra metadata that's attached to the schema that then is processed and then interpreted by the runtimes to know how to execute, take these IDs and send these IDs to this service so this service can look them up, for example. That seems to be the typical way. It's where that's what it's needed for ultimately is to perform that, right? When you're joining data across two sub schemas, you know, how do you do it? You need to take some IDs from here and they need to go there. How do I know which IDs to take and which ones to send? That seems to be the main thing that they're all capturing. There's just different ways of capturing that information. Or maybe we don't even need to capture it. Maybe it's just, you know, that's, it can be, you know, inferred. But it seems like there's a breadth of solutions out there from what I've seen.
Identity is one of those things that's been a problem in GraphQL for a while because we don't specify identity in the GraphQL spec. We do, of course, have the global object identification specification that Relay originally wrote. But that is, you're correct, one of the things that many of these solutions have to solve in one way or another. So I think Apollo Federation, for example, like indicates it explicitly. Atlassian's Nadel does it with an external file that sort of describes the schema that exists separately. But in either way, this needs to be indicated. Now, what I would really like to see is a grid comparison for each of these different like shared topics. So identity is one of these topics. If it turns out that everyone represents identity by indicating somehow that these, you know, this list of fields produces the identity, and then there is this thing that you can feed that information into to retrieve that record, that would be very valuable to see those approaches written down, because then we can say this is a common thing. It's solved in much the same way in all the different ones. They've got different terminology for it. They've got like different, you know, directives or metadata or whatever to represent that. But broadly, it's the exact same problem. Whereas if it turns out that some of them don't do that and don't follow that same pattern, that's also a valuable piece of insight. And I would really like to see that for each of the different solutions, like schema merging, stitching, modules, federation, Hazura's GraphQL joins, Atlassian's Nadel, you know, Pedrag's internal systems, you know, all these different things. I'd love to see for each of these different topics. I pulled a few of them out when I raised the original Composite Schemas RFC. So like identifying what the schemas are, identifying how we know whether to merge types or not, which is one of the things that obviously Jakov's proposal talks about, how to actually retrieve things. Now, I don't think we're anywhere near the point where we would want to actually specify the act of actually fetching this data. I think there needs to be different approaches there depending on different things. So like Freddrag's got this great example of the client actually is responsible for going off and doing this and then doing that versus having some kind of gateway do it. But the indication of the identity, I think, is very valuable. So if someone was able to take on the work of comparing all these different solutions, or even just preparing a document so that the different vendors can fill in, here's our approach to this problem, that would be very valuable.
If we're open to perhaps a little bit more unorthodox / contentious solutions, something that worked very well at Kensho is having no type merging in the composition layer. Hear me out, I know it sounds crazy. Every type comes from its own schema. Any types that happen to conflict, that happen to have the same names by definition conflict, and one of them has to be renamed, or both. That makes the composition logic a lot simpler. At composition time, you can inject additional fields that refer to types across schemas. So you could say, you know, user has a library that points to list of book book types, and where book is defined in another service. And as a layer on top of the composition, we had a schema reshaping pass, essentially, a set of metadata that allowed you to define things that are essentially macros, just syntax sugar. So you get to pretend that some edge exists where it doesn't actually, it's a composition of several edges, or you get to pretend that a field or a new type exists where it's actually a composition of several different fields, or it's something a little bit more complicated. And before execution, all of these macros just get expanded. They just get desugared, and you still get the straightforward underlying, every type has a clear owner and a clear ID, and every the execution system knows where it comes from and who to ask for it. While the user that is writing this query still gets to pretend that the schema is shaped how they would expect it and like it to be, even though that's not actually the case on the underlying services. That was a lot. I hope that made sense.
So as a clarifying question, are you saying each field or rather type, like an object type, says exactly where different types are defined? So kind of like a specified by for a scalar, it's saying like, this is where that comes from? Sort of.
So in the composition layer, you feed it a set of schemas that have names just for convenience's sake. And for any type in the final composed schema, you know which of those names, specifically a singular one, that type came from. Whether this is indicated in the SDL representation of the composed schema or not is kind of irrelevant. You could imagine it being a specified by or something else. And then any edge, right? Any field that is not of scalar or list of scalar, nested type, could either be within the same schema, right? So go from a type to a type that happened to be in the same original schema, or could be crossing a schema boundary and therefore be injected at composition time. And that lends itself very nicely to this client-centric execution, because then you take a look at the composed query. For every edge, you can just analyze whether it arose during composition or whether it's internal to one of the schemas. If it arose during composition, you can cut it with some straightforward rule applications. Get a set of queries that are confined to one schema separately, one schema each. Execute the components, and then just connect the data sets back together. And that desugaring step before all of this lets the user still pretend that, my user type is actually defined in two different services. My user type that happens to be defined in two different services is actually one type. Does that make sense?
I think I'm following. So you're essentially saying there's a universally unique identifier that they all use, and if they share that identifier, the composing service or whatever it is can stitch them all together however it likes. It's like an opt-in for every type.
Sort of. Let me see if I can come up with a quick example. Let's say that I have a type user, and this user owns books, but the book information is stored in a different service, so we'll have to do composition here. But we'd also like the user type to have a number of books owned field on itself, right? And this is clearly something that it doesn't itself own the information for, so it has to come from somewhere else. I'm saying this number of books owned field is a figment of the imagination of the user writing the query, right? It's one of these macros that is defined to be something else under the hood, right? That originates somewhere else and is actually a different query. It's actually behind an edge on a type somewhere else that the user just completely doesn't see, because it's just it's syntax sugar. It's convenience. And after doing this step, then every type that appears in your schema, you know which service it came from. So when you're talking about users, you're talking to the user service. When you're talking about books, you're talking to the book service. And which books are owned by a particular user is one of these schema spanning edges that was injected at composition time where you say, okay, in order to look up, which book is owned by which user, you can reference this field and this schemas type and this field and this other schemas type. Does that make sense? I'll see if I can. I'll see if I can write it down.
How did you guys solve sort of the way that when the books go to users, the user, like books have an ID of user, but maybe not all the user metadata. So you go to like the user service first, and you grab the users that met some criteria, and then you take those IDs and then you send. How did you know which IDs to send to which one? How did you capture that metadata?
Yeah. This was metadata that we fed into the service that was doing the composition. So when adding the, user.owns_books edge, for example, we would say this is a one-to-many edge, a many-to-many edge in this case. Actually, if we're talking about specific like book instances, a one-to-many edge that connects user's ID type to, books book ID, user.id field to book ID field. And so you could traverse this in sort of either direction by fetching one of those fields and then feeding them into one of the filters on the other side.
And is that data typically authored by like the service owners, or is it authored by like a centralized team that's sort of like responsible to sort of put together that relationship? Like who's responsible for discovering that relationship and putting it into the service?
Right. We were lucky in that we actually had a metadata system that just had a SQL database of all of the different data sets and how they all interconnect. There was a team whose job was to maintain this, and we just read that metadata and connected it up.
Awesome.
Udred, are you okay to fill out that example in the notes? I wasn't able to keep up for that bit. If that's okay.
I'm happy to fill it out in the notes. I was actually thinking about adding it to the glossary vendor specific section.
Yeah, even better. I can reference it in the notes. Cool. Sounds good.
Johnny, if you add that as an action item for Predrag, that would be a good way of tracking it.
No problem.
Well, this has been a very fruitful meeting, I think. We've discussed a lot of different topics. I think the metadata is particularly interesting, and it's great to see the various documents that we have working their way out, being more defined, because, as I say, the more shared vocabulary we have, the easier it will be for us to progress on these topics. I would like, if possible, for everyone to have a look through Yakov's pull request and see whether it meshes with their ideas of what schema composability is. If we have agreement there, that's fantastic. That's a great starting point. If we don't, I'd love to dig into those ideas and figure out why we don't have agreement there, and find out where the actual commonality is. Is it a smaller subset of that? I'd like us to keep in mind that we're not trying to specify the one way to do schema composition. We are trying to look at the existing solutions and find the standard pieces, and then maybe specify just those bits so that everyone doesn't have to keep reinventing the wheel. But I very much do not want to limit innovation here. We need to keep people coming up with new and better solutions. Predrag's one in particular is a very interesting solution because it's quite distinct from all of the other ones that I'm aware of. So things like that should always be allowed, supported. If there's nothing else, I think it would be good to call the meeting to a close. And the next meeting is already up on the in the repository. It will be on the 8th of September. So see you all then.
Bye. Thank you.
Bye-bye.
Thanks,
Thank you.
everyone.